Be Jaden. All right.
Your big head's in her way still, somehow.
Now how I go see?
So
Sit down low.
right here, what we need to remember if focusing here is simple random sample is one of those really technical things that they do ask about on the AP exam some. So remember, every random sampling makes it so that every individual has an equally likely chance of being selected. Okay, that's the definition of random sampling.
Simple random sampling is every group of size n?
Right, every group of size n. So like when we talk about a stratified random sample, right? So we've got a stratum here, we got a stratum here, we got a stratum here. And so what we do is say we select 5 people from this stratum, right? 5 randoms. 5 randoms from here. And so how many total have I selected?
Like 15.
15. But in a simple random sample, it would have been possible that I get all 15 from here. Or 10 from here and 5 from here, right? So everyone is equally likely to be selected. But in a simple random sample, every sample of size 15 is equally likely. So it's not just each person being equally likely to be selected. It is every subset, or every sample of size n.
What do you look like that?
Yeah,
See how
right.
quickly I was able to get to my camera at?
That was wild. A whole extra second. Or I had an extra second. Okay.
Well, why don't you stop?
Okay, right here. So stratified, remember, what from experimental design is stratified random sample very similar to?
Blocking.
Blocking, right? So in stratified random sample, we make sure our groups are homogeneous, right? But there's very clear distinctions across the strata, right? Whereas with a block, we make sure that the block is very similar and we randomly assign to treatments from within the block, right? So remember, like we did that one in class where we looked at the cholesterol level, and so we blocked everyone on their initial cholesterol, so the 2 highest were similar, then the next 2 highest, and then the next 2 highest. And so then we randomly assigned one person from that block to one treatment, and then the other person to the other treatment, right? So you randomly assign half the block to one treatment, half the block to the other treatment. Now, what is it called specifically though when the block's only 2? There's a term for when it's only 2.
What does it start with?
An M.
Match pairs?
Matched pairs design. Yeah.
Close enough.
He literally.
I say versus pairs.
It is matched
I was
pairs.
halfway there.
You were halfway there. Systematic. Do we remember what that is? It doesn't show up very often.
It's like every five. Every
Right.
fifth.
Every number.
Yeah, so if you're like, oh, I'm gonna select 20 people, and you randomly generate a number 1 through 4, and so let's say you generate a 3, and then you go every 4th after that, or something like that, right? So it's every nth person. All right, so the real thing that we need to focus though on is study design. So what's the major issue with observational studies? Bias. What does it mean for the sample to be biased?
It repeatedly misses the mark.
Why would it repeatedly miss the mark? Because of what?
Bad sampling.
Or bad study design.
Yeah.
So remember, it's not always just bad sampling. Like convenient sampling, subjective sampling, that's always bad sampling methods, right? It needs to be random. But even if you do random sampling, if you ask the question in a way that causes them to respond in a certain way, that's still going to create bias, right? If you randomly sample, but still 90% of the people don't respond, that's still going to be biased, right? So, in general, it's a biased sample when our samples do not look like the population, okay? And the AP exam does ask about that regularly. So, if it asks about making an inference about a population, 1, we need the sample to be representative of the population, otherwise the prediction is bad. The other thing is, if you're going to claim that it's biased, it is helpful to identify the type of bias, but also you want to make sure that you explain how the sample will be biased. So there was that one question from AP Free Response that we looked at, I think recently, I think it was on a test where we looked at the physical fitness. You remember that? And there was the question of, is the physical fitness actually less, could they complete it in, or is the true proportion who could complete the obstacle course less than 30% or something like that, right? And they got a bunch of volunteers to do it, and the true proportion was something stupid like over 50% could, right? Well, one, that's not evidence towards the alternative, so there's no need to do a hypothesis test. But more importantly, what's the issue with using volunteer sampling?
They all probably want to, they're probably already like fit, that's why they want to.
Overachievers.
Yeah, well, they're overachievers, but in general, like, are you gonna volunteer to do something that you know you're gonna fail?
Oh.
No, right? So we are overestimating the true proportion who could complete the obstacle course. And so you need to say, hey, it's biased because only people who think they could do it would volunteer, but also what direction is it gonna be biased? Do you think it's gonna represent those who can do it, or that underrepresent? Yes,
Over.
over in that case.
Obviously, what if we, I wonder, I would bet you could intentionally do like bad study design in real life and convince some
So I
dumb
can see
people
the deep skin.
and like get like some like really like good outcome because of that,
Maybe,
like in the study,
sure.
but like in the opposite.
Jade.
All that to say though, we want to make sure that we have unbiased samples so that the samples are representative of the population. So beware of voluntary response bias, be aware of convenience sampling, be aware of subjective sampling where you choose. And so we want to make an inference about the population. We can only do that when we reduce the effects of bias. By the way, what do we never say we do with bias?
Eliminate.
We never eliminate, we just reduce the effects as much as possible.
I just thought of an idea. Okay, we have volunteers take a pre-calc test, right? And we show that like the majority of Hillcrest students can like do good on pre-calc tests. So we need a Calc BC class. That's just proof
It's
that we need
over.
work.
It's over, bro.
That's
Yeah,
proof we
it's
need
too
work.
late
Rip.
over here.
Yeah,
It's over.
But would that work? I mean, come on.
probably not.
No.
I just realized we should probably look at the foundation. We'll go back up to the target stuff. So don't forget population. That's who we can make an inference about. It's who we're interested in. What does a question need to have so that for the question to be statistical?
Huh?
What does a question need to have so that we can
Numbers?
consider it to be statistical? Nope.
What?
So let me ask you this: what year was the University of Alabama founded?
1931.
It was 18.
1831.
Sorry.
So is that a
You had the right-
statistical question?
No,
Why not?
because it's not asking about the population.
Well, there is no population to ask about, yes, but there's another reason. It's a fact. There's no variability in
Right.
that response. So, if I were to ask the question, hey, what is the population of Hillcrest High School? That's a fact. Like, there is a certain, or what's the size of Hillcrest High School?
It really
It's a
does
fact.
depend on the day.
Shut up.
But a better
Enrollment,
question,
like enrollment.
right, how many people are enrolled at Hillcrest High School? And yes, it can change,
It
but
changes a lot.
a better question, a more statistical question that would have more variability is how many students attend Hillcrest High School each day? That changes daily, right? And so a statistical question has variability at play. Okay, a statistical question has variability in the responses. All right, so variable, things that can change. Categorical, the responses fit into a
Category.
category. Does that mean there are no numbers involved? No, because you're going to count the number of people or things that fit in the category. Quantitative, the response is a,
Number. What like?
Countable
like,
number.
Yeah, countable or measurable?
Measurable.
so a quantity.
Yeah.
It's countable or it's measurable,
Right.
right? So how many hairs you have on your head, I'm not gonna measure that, but I could count that. I will never count that, but that is something you can count, right?
We can take
The
a
number
random
of-
sample. We can take a random sample.
No.
Right.
Bye.
Like a certain area of it, okay. Retrospective versus prospective studies. This has not been on the AP exam long, it's very rarely actually on the test, but what is it to be retrospective?
Pass or
Past.
So you look at past data that's been collected,
All of those.
right, and then you just make a prediction off of that. What about prospective?
You
Find your own
project
data.
the future, you predict the
Yeah.
future.
Stuff.
Wait, prospective.
So you
What gives us an-
select a sample, and then you follow them over time.
Oh.
Oh, like
Why
a
don't you say
Oh.
like longitudinal?
Yeah, yeah,
I feel like that's
yeah.
better.
That's not what they use on the AP exam.
Okay.
They're not gonna say longitudinal. They're gonna say retrospective and prospective, okay?
Yeah, I like longitudinal.
Congratulations, it's not an AP exam, so who cares? All
It
right,
might be.
at least for your exam
It's on
tomorrow.
here.
All right,
Watch it be on there. No, because we just took the 2017 mock and it was on there. It was on the 2017 like
It
MCQ.
is, but 2017 was before the new course and exam description was released, and the new course and exam description does not have longitudinal anywhere in it, but good try.
It still said longitudinal. Oh, hold on.
You kinda caught it.
I was gonna say.
Observational study, sample survey, what's the difference?
Observational is only like inference for a population.
Oh.
Is that different than a sample survey though?
Oh wait, no. Oh, I thought you meant an experiment. Oh,
What the freak is a
you
sample survey?
observe observation, or you observe.
I'm asking this
like,
question.
You observe the sample. and
Okay, so you observe the sample to collect your data versus a sample survey, you ask them questions. It's a
Oh.
survey
Oh.
of a sample.
Oh.
Okay, so observational study, observing to collect that data or reading through information, but sample survey is where you directly ask humans questions, okay? A census,
Ask everybody.
ask everybody in the population, how often can we do a census?
Um,
Next to never, and if we
Unless-
could, then we
Unless
never
it's on the
need.
ACT.
It just asked a question about what a census was.
We do a
Essentially.
census of our AP Stats students in this
Yeah.
building.
Okay, so don't forget, what's the goal of observational studies and sample surveys? To make an inference about a population, right? So the whole goal is always to make an inference, right? A prediction. But if it's an observational or a sample survey, it's to make an inference about the population, which is why we need our sample to be what of that population?
representative.
Representative of the population, which is why I need randomness. Whereas if we have an experiment, what is an experiment?
Cause and effect.
That's what we're looking for, cause and effect, but what is an experiment?
You give a treatment to
Treatments.
your subject or
So-
experimental unit.
The researchers assign treatments to the experimental units, right, to test for cause and effect. And what's the problem that we can run into with experiments? Confounding, an extra variable that can explain the response variable, but it's not what we're interested in. And so we have to reduce the effects of confounding as well. All right. I think we should be good on all of those. All right, so in the target, what we still haven't talked about. So so we already addressed the idea of confounding variables. So experimental units, what do we mean by that?
Things that are being
The
treatmented.
So what the treatments are
The
assigned to or applied to, right? So,
treatmented.
go ahead.
Can the treatment also be no treatment?
I mean, there could be no active ingredient. It could be a control group, right? But it would still be a treatment, right? So if you don't apply anything, it's still a treatment. All right. But yesterday, Braden was working on, where is Braden? He needs to be here. He's taking that test tomorrow.
You probably sleeping.
In the hospital.
He's, every single time he's not here, he says that.
Because that one time when Jaden said.
Can we get M&M since no one else is here?
Serena.
Only playing. Don't
Serena
even
for
know.
president. I know, right?
She's already running for president.
But we move on to the president,
He's gonna
guys.
answer it in the shower or something stupid.
Dude, I
He
swear.
just, they're glad he's definitely in the shower.
Oh
my god.
Thank you.
Hey, we wanted to know if you were in the shower.
No, we did not want to know that. We want to know where you are.
Good job.
Hold on, I'll
It's
send
right
you one.
here.
No.
Stop moving your hand away.
Hey guys, we gotta get going. We got
Sorry,
a
sorry.
test tomorrow.
We're lost.
My B.
My BG.
Okay. So, what was I gonna say? Yesterday, Braden was working on a question where they were using, and this is an older question, but they were using different hitches and testing the draft.
Oh my
of the
god, I
hitches.
hated that one.
But one of the things we need to recognize is there was no replication because they only used the hitch on one
Two
field.
No, it was two fields.
Whether they
Oh,
used each
yeah.
hitch on a field, right? So they randomly assigned which hitch they used on which field, but they only applied it to one. So the entire field was the experimental unit, right? It's what is being assigned to. There was that one question we've had on a test, I think, where I asked about the experimental units for the twins, maybe, and it was a dermatology one.
Oh my god.
That was a more recent question, and we need to recognize that the experimental units were not the twins, because they didn't apply the treatment to the set of twins. It was the 72 individuals, right? Because they applied the treatments to one twin or the other, right? So we have to be careful about that. Explanatory variable or factor, right? So keep in mind the difference between a factor, an explanatory variable, and the levels or the treatments, right? So I always give back to this example because I think it's classic. It's from science. Like if I'm wanting to know what can affect the growth of a plant, what are the factors or explanatory variables that can affect the growth of a plant?
Light,
Water,
Carbon.
light, huh?
Cold, wind.
the carbon cycle.
Temperature, carbon, how much carbon dioxide's in the.
We've
So
gone
these are
over this
all-
before.
Right, I'm reviewing.
We did this in bio. We already did this in bio.
And I also use the example before. Anyways, those are all factors,
Okay.
explanatory variables are factors. But then I can do different levels within each of those. So I could say, oh, and then like sunlight, right? I could say, oh, it's gonna get 12 hours of sunlight each day, 10 hours of sunlight each day, 8 hours of sunlight each day. Oh, it's gonna get 5 centimeters of water a week, 2 centimeters of water a week, 1 centimeter of water a week. Those are each of the levels within those factors. And then it's the combinations of those levels that give me my treatments, right? So it would be 3 and 3, so it'd be 9 total treatments. Okay, so 12 hours of sunlight with each of those amounts of water. 10 hours of sunlight with each of those amounts of water. So keep that in mind. Levels are the different values within each variable or factor. The treatments are the combinations. And then you already brought up control group earlier, Jaden, that when we have a control group, we have a baseline with no active ingredient treatment, right? But one of the big things you always have to have is comparison, so that you can compare how the treatments worked. Other elements of study design are we have to randomly assign, we have to replicate, we have to directly control the confounding variables that we know about. So remember, direct control allows me to directly control the confounding I'm worried about. Random assignment allows me to filter out the effects that I cannot account for, right? Blocking is another thing that allows me to directly control for factors or confounding variables that I know about. Replication, again, allows me to filter out things I'm not able to perfectly explain. Completely randomized design, each individual is randomly assigned to a treatment. And that's in comparison to a block design, where you create homogeneous blocks and assign half the block to one treatment, half the block to the other treatment. So you have to identify what makes them similar and how can I base it on
So,
that. Go for
Cluster
it.
is heterogeneous, right?
Cluster samples, and that would be under observational studies. Yeah, so the cluster is heterogeneous, and we would think that that cluster all on its own is representative of the population. And so we would randomly select the entire cluster or a couple of clusters and do a census for that cluster. But it would still be a sample for the overall population, okay? Placebo effect, gotta test to see if they think a thing is affecting them or not. Blinding, what does it mean to blind an experiment?
They don't know what's going on.
Who's they?
The
The
subject
experiment or the experimenter.
Subject
Or both.
or the experimenter, or not necessarily the researcher, but at least the person collecting the data, right? A lot of times you have to have some way for the researcher at the end of the study to be able to pair the data with an individual. So like right now, Ms. Williams and I are both in a study we're in a fellowship at the University of Alabama, and they're collecting data, and the researcher, Dr. Zelkowski, has a separate person that I'm actually meeting with on Monday for the end of this fellowship, and he collects all the data from us. But Dr. Z has no idea whose data goes with whom.
Who's doing
So what is he supposed to do again? What's the point?
He is studying how the courses and the relationships we've built with others in the fellowship has affected our teaching and philosophy over the last 5 years.
So do you just hate
So,
everyone there? Is that
so
why
do
you're
you,
saying
do you,
this
do you just like,
What?
do you just like explain like how your relationships are, and then he like objectively?
Well, so there's that, but also like there's surveys that we answer at the end of each year, and they've tracked it each year over time. And so we do interviews each year as well. They look at the projects that we've developed. So like I work with, so there's 3 different cohorts. I'm in the 2020 cohort, and
Ooh.
everybody in the 2020 cohort, we all banded together And we developed a learning community for teachers in the city and county. So like we talk about those projects and like what we're doing.
You already talked about this, but I never heard anything about it after, so I thought you abandoned it.
No, we're still doing it.
Do you still do like the TV show or something that you said you were gonna do? Or not TV show, but like video things for like math educators?
No clue what you're talking about.
I
Alright.
think you were gonna do
There's an
that.
exam tomorrow.
Yeah.
Freshman year, you said
And so remember, an observational study looks at association versus an experiment at causation. If there's what type of difference in the data? Statistically significant, right? So we started talking about it all the way back there. And so we also talked about sampling variability. We know more about that now. That's the idea. The question was statistical significance. Could this sample that we got, could that or more extreme have happened by chance alone just due to sampling variability? Or do I think my assumption from the beginning was wrong? All right, so that's the big thing there. I think that's all that I wanted to talk about.
We do?
Make sure that you know how to describe a method for sampling that is guaranteed on every single test, that you have to describe how to sample or how to assign treatments. What's the 3 things you gotta do? Label,
randomly select.
Yeah,
Randomly
generate
select.
and select, right? So
RNG.
label all of your individuals with a unique number, randomly generate with a random number generator, blank number of unique identifiers, and then select the individuals for the study.
But you, is it like, don't you have to also say like blank numbers, blank through blank?
You do, yeah, thank you for saying that. Yeah, so if there's 300 in the population, randomly generate 30 unique identifiers from 1 to 300, which I feel like is silly.
10% rule. I mean 10% condition.
Yeah, that's why I meant it. That it's goofy, I think, that you have to clarify that. I feel like it should be obvious, but they require it. Yeah, alright. So, the other thing that y'all were asking about was, chi-square stuff, right?
Please just go over probability, because like I didn't know any of that's to go 1 minus whatever.
Okay, so can you find one of those free response questions? By the way, did we find any chi-square ones that we can talk about?
I mean, yeah.
So which questions do we want to look at? I love the, I've done this a billion times, I've assigned it once, maybe twice.
Twice.
Maybe.
We can do this one.
So 2024, number 5?
Yeah.
I wish I'd put these in order, that would have helped a whole lot, but
Yeah.
that's a future problem.
Wait, can we go over 2021 number 3?
2021, number 3.
Don't do 2024 yet, I was gonna do that later.
Shut up! Oh my.
Maybe you should have done it when I assigned it. That's
I
wild.
was doing that earlier, but I was doing other problems around.
I'm scared.
Wait, I want to take a picture.
Raise your yeah.
That was funny, that was a good one.
How do you? Okay, yeah.
Weird way of opening it. How does your phone already have scratches?
I don't know.
You said 2021, number what?
3.
Number 3.
I
That one.
think.
So,
I can shoot my eyebrows.
don't forget, I did send y'all the copy of this with my main ideas that I identified. So to increase morale among employees, a company began a program in which one employee is randomly selected each week to receive a gift card. Each of the company's 200 employees is equally likely to be selected each week, and the same employee could be selected more than once.
Oh, my bad.
Okay, you good?
I was just yawning.
That was
He makes some
the
weirdest
Yeah.
noise whenever he yawns.
It was like,
yeah.
Okay, so each week's selection is independent from each other. So just right away from here, what's some key ideas that should jump out at us?
selected each week.
Bacon.
Bins, right? Like, it's binary. They either get the gift card or they don't. What's next?
Independent.
Independent selection. Literally each week's selection is independent.
So do we have to show bin? Like, do we have to write out bins on this?
Not here, but they do want you to check conditions. But we'll come to that in a second. It's a fixed number of trials, right? There's 52 weeks in a year, and the same probability each time, right? That's the idea of it being equally likely to be selected each week. And the same employee can be selected more than once, so same probability every time. And what I will say is this, when I start looking and thinking, hey, is it binomial? Writing out bins and checking bins is a good idea, right? So when we say, define the random variable of interest and state how the random variable is distributed, bins, checked it. Binomial random variable, what else do we need with defining the random variable of interest?
Contact.
We need context, right? We always need context. So I would start this with context. Okay, so the probability that a particular employee receives at least one gift card in a 52-week year is defined by a binomial random variable with what?
Oh my god.
By the way, notice what I did right here is I just took the, what do you hear?
Nothing.
Here are keys for me, but it's especially the fourth district. I think
Right.
it is.
What did I do? I took that what?
Contact.
Context. I literally just ripped it, right?
So,
Straight from there. What?
So the random variable, what?
The random
So,
is how
the-
many gift cards an employee receives in a 32
Oh.
Right. The
week.
probability that a particular employee receives at least one gift card, or it really is the gift card, how many gift cards an employee receives in a 52-week year follows a binomial random variable. What else do I need?
It says state how the random variable is distributed. I don't know.
Oh yeah, you need your parameter.
You need your parameters.
Oh.
Notice, there's a fixed number of trials of 52, right? And there's a probability of 1 out of 200. Right? So it's how many successes out of those 52 weeks getting a gift card. And so, start with your context, identify as a binomial random variable, define your parameters. And how do we tell a binomial versus a geometric again?
The chances until success.
So the geometric is the number of trials until a success, right?
So
Which is bits. Yes, Serena.
how do you do the at least one gift card?
Well, I was gonna get to that in a second. There's
Okay.
two different options.
It's just easier.
Because notice right now it's just a define. Right here, it says determine the probability that a particular employee receives at least one gift card. So there's two options. One, we just identified this as a binomial, didn't we?
CDF.
So we could do a binomial CDF with what for the lower bound?
One.
1, what for the upper bound?
52.
So they could win 1 or they could win 52 and then put your trials and your probability in there. We'll do that in a second. Or it could be 1 minus the probability of winning none. If it's at least 1, it's 1 minus the probability of none. Well, what's the probability that they don't win 1 at all?
199 over 200 to the 50
So the
second power.
chance that they don't win 1 is 199 out of 200, right? And then they don't win 1 52 times.
Dang,
That's insane.
they suck.
Yeah, luck.
I like agate.
Those villains.
Agate.
So let's check those two probabilities against each
Why'd
other.
you
What?
buy my paper?
No, I didn't.
Why'd you buy my scribble?
She's Serena.
That's,
Alright,
that's not
While
my,
my calculator is loading, let's look at this next piece.
that's not my pen.
So how would we calculate and interpret the expected value for the number of gift cards a particular employee will receive in a 52-week year?
I don't know what my formula sheet is, but that thing that's in the box at the very top of the,
Let's see if I can pull up a formula sheet.
it's underneath the, like,
NP.
it's underneath the
NP.
non-cage probability stuff, and then it's at the top of the
NP.
cage probability stuff.
NP.
I don't know if I'm Shut up!
I sided with Peter. But notice section 2 right here, probability distributions, and we have our
Discrete random variable.
discrete random variable, and then remember binomial and geometric are just special types. So the mean is
What's
just
special type?
n times p. That's right.
Wrap it up.
Why is my
It's like a Pokemon.
oh
I think we
I
decided.
know what my username and password are.
Texas Instruments.
Why was I thinking that? Like, literally in my head, I was thinking it.
Think what?
Taxation's like,
Oh.
as soon as you said, I was thinking, like,
Calculate.
That's weird.
Alright.
I'll draw it more.
So just remember here,
Yeah.
it's 1 out of 200 times 52. So what's the expected value? 0.26?
Probably. Is that you right?
You just do 52 out of it. So, I'm gonna go back to A in a second, but the expected value of the random variable x is equal to n, 52, times 1 out of 200. .26.
Good
Right?
job, Peter.
Thank
Okay.
you. Thank you.
So now here's the thing to remember, how do we interpret that expected value?
Trial.
Okay, so or in the
Long run.
long run, right? So in the long
But you
run,
said not
or
to use in the long run.
who said that?
You did. You said always say after many, many trials,
you-
because in the long run is inaccurate now or
You
something.
said,
crap
yeah,
like
you said
that.
something about that. You did like some research.
Don't matter.
Okay, then go back to after many, many trials. So after many, many trials, a particular employee could expect to win 0.26 gift cards in a
2 weeks.
year,
Yeah.
right? So
That's
many,
fair.
many trials, yeah. The only, because I mean, there's 200 employees, right? So we can check it in a second, which I'll pull up the thing.
What
But
scenarios do you need to say that again in after many, many trials?
say it one more time.
And what scenarios do you need to include after many, many trials?
For
Probability.
expected, yeah. For the mean.
What are like
Can
sampling
be-
distributions?
A sampling distribution
Or for all.
literally already has many, many trials. That's why it's a sampling distribution.
There you put it.
For what though, about the sampling distribution?
I don't know. Like, what if you have like a mean?
I'm gonna draw sunset.
It's like,
That's okay, I don't need
I'll
to.
take mine.
or like after many trials,
so-
the expected value is blah.
Distributions of binomial CDF,
Ready?
52
the
trials,
next guy.
1 out of 200 for probability, 1 to 52. 1
This is
minus.
the next guy, right? Hold on, give me some time.
Give me this, right?
So this is it for me. Slowly.
So notice,
Yeah.
okay, right here. 1 minus probability of none, same as a binomial CDF.
That's a big fraction.
I know, right? I was like, why did I
geek?
let it?
I can't see.
So, same exact probabilities. Okay, so what was this, 2021? Oh, and then notice here C. Suppose that Agatha, an employee of the company, never receives a gift card for an entire 52-week year.
Rip.
Based on her experience, does Agatha have a strong argument that the selection process was not truly random?
Nah.
No, what is the how could we do that, or how could we explain this?
It's above 0.05, which is,
The probability of getting those gift cards
Is expected.
is not so unlikely as to think that, you know,
I feel like you
Just
could
like
probably
constant
justify this either off of the expected value or,
Because the expected value is less than 1.
right, so the expected value for any particular employee is less than 1, so no employee should expect to win 1 in a year.
but I'm
I feel like that's a good argument, or I do like this informal p-value, right? We have just calculated the probability of getting at least 1. Well, the probability of at least 1 is only 0.229 or something like that. That's not super likely that you are guaranteed 1,
Yeah,
right?
it said you can use both.
Huh?
The rubric, like it said you can use both.
How do you remember that? Or did you look it up?
I looked it up.
Oh, okay.
Well, like, maybe like a couple days ago.
2021,
We're just,
what number was that, 3?
Yeah.
where's left?
he's trying to get that 5 so bad.
I'm not worried about
He's
it.
gonna get that perfect score.
I respect and appreciate him going above and beyond to make sure he gets it.
That's true.
Yeah.
I can too.
So notice random variable is the number of gift cards a particular employee receives in a 52-week year. Distribution is binomial. Event of interest, and direction of the event in the calculation of the probability. So yeah, make sure that you clearly communicate
You look
the way that we're calculating these things and the correct probability. So let's see, right here it does say if the random process of selecting one employee each week to receive a gift card is repeated for a large number of years, right? Each employee can expect to receive about
Turn to iPad
0.26.
no matter what.
Oh, that's what we need.
I'll check
No,
it in the next
it can be
Tuesday.
in the long run. This is what we have to make sure we include.
What was expect, isn't it?
On average, they can expect on average.
Isn't it, does it not like the same thing as expected?
I think so.
Yes-ish,
I
but,
mean, you kind of addressed that for like when we did like the slope thing.
yeah, that's true.
Yeah, because it didn't say expect on there. I think as long as you have either, right?
You go, hold on,
Here's what it is.
So, right here, well, right here it says at least two of the following three aspects. Concept of repeating the selection process over a long
yeah, it's
period of
just the
time.
average or.
And
yeah,
then concept of an average or mean,
Yeah.
and the context. So there's, it only required at least two of those following things. But sometimes they're a little bit more nitpicky.
Whatever, I do what I want.
I'm hoping our graders are extremely generous.
Me too.
It's not about the graders, it's about the rubric. Like, people go behind and read, behind your graders every now and then to make sure they're satisfying the
They have a
rubric.
table leave here too.
I know,
That's what I'm
but
talking
there's
about,
still
table.
some subjectivity to
I
it.
mean, yes, but not that much. Okay,
How about the reversal?
and also a different person scores each question. So like, I mostly worked on, I'd have to go back and look. Oh, I have it down
Well,
there.
then,
So will a different
I-
person grade each of my bio
Yes.
things?
Yeah,
Yeah.
each free response question is, so like, I graded one question the entire time last year until we ran out of that question, and then I worked on the question 5, I think.
So wait, what if you wrote it in the wrong section?
What?
Not,
well, they fix it manually. They do some
They
post
do.
processing.
okay.
Okay,
But wait, hold on. Okay.
yeah,
I hope that the rubric graders, the rubric makers were
Rubric.
extremely generous.
Me too.
The scoring guideline creators,
yeah.
Do you
there
think
go.
this rubric has been getting easier each year?
okay.
No.
I seem like guys.
There's some things that they've gotten nicer about, but there's some things where they're like, hey, if there's 5 things that we're looking for, you only have to hit 4 of them to get an E. So that's been nice, but I wouldn't say overall it's gotten easier. Okay. Alright, what was the other one we wanted, 2024?
Number 3.
This one? Wait,
Yeah.
number 5 you mean?
Yeah, whatever.
Okay.
I was trying to be impressive like Peter, but.
So, number 5 here, again, I pointed this out to Serena earlier. As soon as we see a two-way table like this, that should make us think of one of two things.
Chi-square probability.
Chi-squared and or probability. Yep. Oh, one thing before I forget, Ms. Livingston, I started to say this earlier, asked me to remind you, make sure that you get here early. They want to start at 8 tomorrow, so try to get here around 7:45. That way we can make sure we can get to graduation.
See, I take the bus, so I might get here.
AP Lang, I showed up at like 8:01.
Then show up at Coach
What?
McKinney's room as soon as you get here.
ASAP.
It's like Rocky.
I will not even be here, so.
So I'm gonna be here.
I should, why do you need me here? You're taking
Can you at least put the
exam.
calculators
Why would you
outside
do
your
that?
door?
Take a calculator with
Yeah, I'm gonna go up and
Wait, I
calculate.
need to
Now,
charge my
today, what if
calculator.
it dies on accident?
Mr.
Well, take
Jackson,
2 with you.
When every time I put one in my backpack, it dies in my backpack somehow. I guess it turns on an accident jumbling around.
Correct, it's
Or-
And so it's always there.
That's why you not be here with
Please.
us. That hurts my feelings.
Sanaya, you're sitting down there, I can't be in the room anyways.
Why?
Well, wait,
You gotta at least like wish
Miss
us
Williams
luck.
has the same one, right?
I can wish you luck from home.
Miss Williams has the same one, right?
Yes.
Can we
He
just
just,
do
he
her?
just wanna use his time off. To
Okay.
use his time off.
I'm gonna feel like 2
That hurts my
extra.
feelings. I thought you'd be there.
I guess I just gotta fail the exam.
What would that do?
Give me
Teach you
motivation.
confidence.
Motivation.
Like Mr. Kid, you're like our uncle, so it's just like.
Unk.
No, I will be working on my maintenance and certification for national boards.
Oh my god.
So it's not just to take a day
I'm
off.
sorry. You look already off.
Okay. So, fully charged iPad, make sure you have your calculator with you. You're allowed to calculate on the whole test. If you want to take 2 calculators to make sure you're good to go, you can do that. But also, Ms. Kowalski will be here, so you can come into the room.
Oh, she's finally
So
back.
this is the day that, this is the one day she's subbing and it's a half day, so we won't even see her that much again.
We
She'll be
probably
back
took
Monday.
probably 5 minutes. Oh,
Should we be back? Oh my god.
back or just?
She'll be back for Monday.
Just,
Because Mr. Kenny's gonna be gone.
why, okay, so.
Why are you always gone? You're like an absent father.
Oh.
You know what they are saying, you know.
How many times have I missed all year?
Like twice.
Okay, I don't
Well,
even know that.
no days.
I missed one, I didn't miss those days, they kicked us out. I missed one day because Alex got sick. And then I am missing 2 days now because y'all are finally done. I waited till y'all are done so I
2
could go
days.
finish national boards.
What about our AC?
2 days, you're not gonna be here Friday either? What's the other day?
What about all the
Tomorrow
projects we
and
have to do?
Monday.
Oh, Miss Kowalski's subbing is because you're not here.
Yes.
Oh, I didn't know.
You have your personal,
Right here, okay, sorry.
Yeah, you're
Bring it all back.
you're
So,
weird.
iPads fully charged. Make sure you have
Probably
calculators.
free,
If
too.
you
That's
want to
crazy.
have 2 to be safe, go for it. And finally, make sure you're here ASAP. Oh, and then she said make sure that you have, is it Blue Book
Yeah.
downloaded and ready to go.
Do you have it, Samaya?
Yeah.
Okay.
And we also need to make sure you know how to have you accessed the formula sheets and stuff on Blue Book?
No.
It's so
we need to do that.
buns.
I
It's
know,
so
I
bad.
It's not that bad.
We'll look at it after
Yes,
we
it
finish going
is.
over. Hey,
We
chill,
should.
right here,
iPads are
hey,
small.
right here, woo, right here, woo. All right,
I had
cool.
a bigger iPad, it's
Shut up.
Shut up. 2024 number 5. Once again, we got a 2-way table. We've got two-way categorical data, or 2-way table with categorical data. So we should immediately be thinking probability and/or chi-square. So we've got these baseball cards our trading cards that feature data on players' performance in baseball games. We're at a National Baseball Card Collectors Convention with approximately 20,000 attendees.
Dang.
She notices that some collectors have both regular cards, which are easily obtained, and rare cards, which are harder to obtain. Michelle believes that there is a relationship between the number of months a collector has been collecting baseball cards and whether the majority of the cards in the collection are regular or rare. She obtains information from a random sample of 500 baseball cards collectors at the convention, records how many full months they've been collecting, yada, yada, yada. So first things first, if this ends up being chi-square,
no.
is this going to be a goodness of fit, independent / association, or homogeneity?
Association.
Why is this going to be association / independent?
It's seeing like if the older people have more rare ones.
One sample.
So like, is there an association between time collecting and rarity of your cards?
Like,
So I'm not going to say you're wrong on that, but by
Like
that
everything.
language, it could be homogeneity as well.
One sample,
like the
2 variables.
variables.
What are you saying, Peter?
It's like conditional, something like conditional.
So there's something about conditional, you were saying 1 sample, 2 variables, right? Notice, how many samples did she collect? 1 sample of 500, and then she split that data into 2 variables. So I'm not comparing 2 different samples, I'm not comparing 2 or more different populations, I'm looking at 1 sample and I'm looking at the data from that 1 sample, right? And so I split the variables. There's another key thing up here. That word relationship should make us think about association or independence, okay?
No,
So,
no.
Notice the bigger thing again though is if we have 2 or more samples, 2 or more populations, I'm looking to see if it's the same across those populations. Whereas here, I've got 1 sample, 2 different variables I'm looking at, the type of baseball cards and the number of months spent collecting. Alright, so we look at part A. If one collector from the sample is selected at random, what is the probability that the collector has been collecting baseball cards for 11 or more months and has a majority of regular baseball cards? Notice, I said probability of intersection. Why? And, right? So how would I annotate this using probability notation to make it clear I know what's going on?
Probability of collecting for 11 plus months.
So 11 plus months.
Intersection majority regular.
So, and you can even just say regular. So majority regular, something like that. But notice, probability of 11 plus months and regular. Like, we're showing work, that's enough and like notation really to show that work. And
I
so,
was wondering about
regular and 11 plus months.
Because I was like, how am I supposed to show my work on this? I'm really just plugging in the numbers.
Well, what you could also do is this.
Oh, it's easier.
Notice that's 11 or more months and regular. And circling up there can be good annotation as well. So is that
That's
188?
not gonna
So,
work.
so does like the circling count as showing your work a little bit too?
I think it would.
Okay. Cause on,
Not this year?
on that bottom part, I also just circled stuff for my work.
I would do that though.
I don't understand, like,
I think that's right.
when to not download, when to divide by like the total of a,
So like, are you talking about with B here?
no, like, I don't understand when to download by a
Divide?
row total or the total.
Download or divide?
So remember, what you are referring to is conditional. Okay, so if it's a conditional, like here, what we're looking at is given that a randomly selected collector from the sample has been collecting baseball cards for fewer than 6 months, so given less than 6 months, what is the probability the collector has a majority of regular baseball cards? So probability of regular given less than 6 months. So now I'm not looking at the whole population. When it was 11 plus months and regular, I'm looking at everyone. But now, who's the only group I'm looking at?
Less than 6 months.
Less than 6 months. Also, remember, Serena, that this is the probability of the intersection divided by my condition. So notice how I'm not looking at everyone. I'm only looking at less than 6 months.
Okay.
So normally what goes in the denominator is your total. Well, my total in this case, only less than 6 months.
Okay.
And so, so fewer than 6 months and regular divided by fewer than 6 months. So notice I'm only looking at that condition. Does that make sense? Okay. All right. So I'm going to come back to that in a second. So what I want to ask or point out to make sure that we remember how to do this, how could I test in this case, just this one, not the whole thing, but just in the one case, how could I test to see if the events regular cards and less than 6 months are independent?
The observed by
Check with
expected.
equal to the probability of regular.
So you're going into the chi-squared, but I'm just saying these two events right here.
Check if it's the same as regular.
So remember, if they're independent, that condition doesn't matter. So if independent, that would just equal the probability of having regular cards. Okay? So keep that in mind. So you're 100% right. If we're looking at the association for all those categories, then I would have to do that.
Okay.
But if it's just looking at these two events, this would need to equal the probability of regular. What's the other way I could have checked to see if these two events are independent?
P of regular under 6 months is that equal to the P of like rare or the regular, right?
You just said the same thing, didn't you?
You could just check the intersection and
You could. I was
Wait,
gonna
could
say
you
this.
You said something the other day, but I forgot what it
No, what's the
was.
C thing?
what, like the base theorem? Oh,
No,
well, base theorem is the same thing.
the complement of
Yeah.
regular.
I would have just done this.
I mean, I guess you could do the opposite.
But what would the probability of less than 6 months given regular equal?
Probability 6 months.
Of less than 6 months, right? Because remember, it really needs to be, yes, you could do the complement, but really what I'm asking is, are these two independent events, right? So I could switch what the condition was and then look at the probability that they're doing less than 6 months. Either one will work. Someone also mentioned the intersection. Yes, remember, if they're independent, don't do this unless they're independent, or maybe to check independence. This intersection would equal the product. So remember, that's only if they are independent events. Okay? What?
I'm so cooked.
You're not cooked.
Please let there be no probability on this
There will
test.
definitely be probably.
There will definitely be probability.
Please. Might just
Look,
statistics. Like,
Srini, go ahead and look at the percentages.
oh my
Go ahead
God.
and look at the
Oh,
percentages.
so close.
I'll do anything for no probability.
I can get.
Alright, really quick. Really quick, part C here, Michelle believes there is a relationship between the number of months spent collecting cards and which type of card is the majority. Name the hypothesis test Michelle should use to investigate her belief. Do not perform the hypothesis test. So we already said chi-square test for independence or association. What would the hypotheses here be?
Probability that there is no association between them.
Slow down. Not a
Oh,
probability.
not I meant H of N is, you know what I mean.
So the null hypothesis,
Why do you
There's no
think each
association
of,
between-
I don't,
there is no association between
the number of months spent collecting baseball cards
And
type of card
Majority.
is the majority, right? Correct. And then the alternative would just be there is an association, right? And again, I like that language better than independent. I don't know why, but the independence always threw me off. It was weird that the null is that they are independent and that the alternative is they're dependent. I go with the association idea.
because null is no.
I guess, I mean, like,
What?
the alternative could be like they aren't independent, so like it's kind of implying that
Right.
inequality.
It's just, I don't know why, but like independence almost felt like the thing that we should never assume they are, so we would try to prove independence, but that's not it. We assume they're independent because of the way these things work out. Now, do we want to quickly go through the full hypothesis test for a chi-square to make sure we understand?
Yeah.
I feel like that'd be.
Just in case.
Just in case.
Watch it be on the test
It's
tomorrow.
gonna be
Watch it be on
just
the
in case
detail.
it's gonna
So
be
here's
number
the,
six.
here's the reality, like I
Oh,
don't.
yeah, if it's number 6, we're good.
I don't think I've seen a chi-square as the like a full inference procedure in a while, and so it may be that they're getting away from it, but it could also be that it's due,
Yeah.
right?
Well,
So,
well, the super volcano was also due a while ago.
okay, as I said, there's two different options. All right, sorry. What's our first step? Choose. So I'm not going to write everything out. I'm mostly going to focus on the calculate portion. But when we choose here, make sure you do your hypotheses and you define your p-value. Is there anything else I'm missing?
No.
I think that's
Alpha
it.
level.
Big.
That's what I meant to say. I said p-value. I meant alpha.
Oh,
So yeah, hypotheses and alpha, and I think that's it for, and then the type of test, right? So name the procedure, your hypotheses, and your,
oh my god.
alpha level.
These block blast addicts.
Block blast.
Right.
does.
Okay, so then what comes after our choose?
Check.
Check.
Check. And so for the check, what conditions do we have to check?
Over 5,
Expected.
Random sound.
So it has to be a random sample, which was it?
probably.
Yeah.
Not probably, it was definitely a random sample. They told us it was a random sample of 500
500.
attendees.
Whatever you
500
say.
is less than 10% of 220,000.
By the way, I think I remember on this rubric, as I scored it, you had to be very intentional about just talking about the attendees at the convention, because that's the population. That's the sample we selected from. Not all baseball card enthusiasts or collectors.
Up to 20,000
You-
people.
Had to be intentional about the people at the convention. And again, not the 500 in the sample, it's all about the population, right? So is there evidence for the population? So check, random sample. Do I have to worry about the 10% condition?
No.
I mean,
Yeah.
wait, I just said it though.
Do we satisfy the
Yeah.
10% condition? Okay. It satisfies the 10% condition. Remember, this is random sampling without replacement. So is 500 less than 10% of 20,000? Yes, so we're good there. And then you already talked about the expected value. Now, remember, the calculator can give you the expected value, right? But what could we quickly do to find our expected value?
Row total times column total over total.
So which one am I gonna look at? Because I'm not gonna do all of them.
Probably like 6. Wait, what? Oh, it is 77. I don't
So
know.
the 77, and what else?
And then the 82. I mean 80.
And 80, right? So notice that's actually the lowest observed count. But remember, we don't care about the lowest observed count, we care about the lowest expected count. And so it's the row total, 77, times the column total, 80, divided by the total, 500, and whatever that expected value is.
So we're finding the expected based on the
Excuse me.
based on the observed.
Yes, the expected is based on the observed. Because remember, it's assuming that we have independence, right? And so if they're independent, then
Oh my god.
Okay, I'm done.
Yeah.
if they're independent, we are taking the, what category was that again?
11 something.
11 to 15 months, right? So we're taking the probability for the 11 to 15 months, and we're multiplying it by the rare,
77.
so the 77 out of 500. Because if they're independent, I can just multiply those two, right?
Yes.
And that would be the probability, but then to get the expected amount, I multiply it by my sample size. And so I'm left with 80 times 77 divided by 500. That's how I get that, right? So the row total times column total divided by total is just a shortcut, but 12.32. So the smallest expected count, and that's what you would have to say there, the smallest expected count is greater than 5, show the work for it. So the large counts condition is satisfied. Do note, we are not going with a normal distribution this time, it's chi-squared. Yeah, skewed right. Okay, so then we move into our calculate. So what are we gonna do for our calculate to set up?
You have to make a matrix.
You have to make a matrix on the calculator, but we gotta write some crap out first.
Oh my goodness.
Oh my goodness.
But what I need to check.
I squared
Okay.
equals observed minus expected squared over expected.
Sum of
Oh,
observed
crap,
minus
sum.
expected
Squared over.
squared divided by expected.
What's
And don't
funny?
forget, I know that you're saying that out loud and we don't, and we should know it, but where else can I find it?
That formula
That
sheet,
formula
that's really
sheet,
hard to
yeah, yeah,
access,
yeah, yeah.
and it's better just to
I
memorize
know,
it.
I know, okay, but,
Well, if we had a bigger iPad.
so what I will say is this, you're gonna need your expecteds, I guess, so we might as well go ahead and run this in the calculator. Really
I
quickly,
don't know where my calculator is.
without doing the calculator, you just plugged it in.
Right.
Without using the calculator, what would the degrees of freedom here be?
3, 4.
1, 2, 3, 4, 5, 6, 7.
Wait, no, wait. 4
5?
times 1, yes, 4.
It's not one.
So remember,
4 times 1.
we don't include the totals,
Oh.
so it's row total minus 1, or number of rows
Oh,
minus
so-
1.
Oh, yeah.
So-
I'll just plug in the calculator and get it, bro. I'm not gonna lie.
So it's like 4.
It is 4.
Okay.
I don't know how to do
I was
that.
so confused.
So
Yeah,
degrees of
I
freedom
need to
here would
remember
just be 4 for our
I need to
calculator
remember that.
distribution.
I need to remember that too.
I need to borrow your-
Alright, so if I'm you, I'd grab a calculator,
Okay.
okay?
I'll
Need a
take your
calculator
advice.
make your matrix. It's
Okay, can you give us
a
calculators?
2 by
Now?
5.
What?
Oh my
Oh,
god.
No, don't, there's what? There's stuff in there.
Exactly. That's how you do it.
You need calculator? Yes, please. Thank you. You did not just put it right there. You're welcome.
You see my file?
I believe her.
Oh, you're believing the.
No, I believe that she would do it.
Oh.
Okay.
Here we go. Much better. That sounded like the beginning.
Oh, I need
like,
to make a matrix.
I'm shocked I remember to do this.
can we please play After Go, sir?
Oh. God, please. Where's you and like stereotyping?
So,
You don't understand.
Yeah, we don't understand stereotyping people.
You do it all the time.
Huh? Oh, since when?
This is just now.
What?
I don't know. I'm just saying crap.
Okay.
Wait, I'm trying my best. Hold on. Wait. No, stop. Dude, I hate this.
Oh, wait, snap.
2, 3, 4, 5.
No.
What's the 2 sample?
Every time I try to click off of it, it just like lowers my number.
What's the 2 sample F?
Yes, I chose the 2.
Serena, hit tab, and it'll go to the next one.
So what's the 2 sample F test?
F
Well,
distributions
6:15,
deal
thank you for
with, or at least when I've used F distributions, they deal with hypothesis testing for
Oh.
variability.
Or we did those.
So,
Oh, so for like
There it
reality.
is.
Yeah, okay.
Computer look.
What the heck?
I remember.
I do not know a ton about F distributions, I need to. Alright, do we have this set up?
Oh, wait.
Almost.
That was 3.
Can you just copy and paste it straight into there like that?
Hmm?
Can you just copy and paste it straight into there without defining it?
Sure, but why do that?
Because it's quicker.
No, I forgot to define
These
it.
conditions is crucial.
What'd you forget?
That actually scared me, first of all.
Okay. So, define your variable, it's easier. Okay.
Defining variables is crucial.
And then, make sure that, so you can run the test here, but remember, it's gonna be better if you go to list and spreadsheets. And also, that brings up, like, if you're gonna do any calculations in your calculator, make sure you name your variables up here at the top, okay? But obviously, we didn't do a matrix here, so statistics, stat test,
Wait.
chi-squared, two-way.
Name, statistics, stat test, 8. Observe matrix.
Oh, I just realized how they calculated the expected.
Are you stupid or dumb?
I was so
It's the same way we do it. It's literally the same way we do it.
Okay,
Yeah, I really said like the first day.
Okay, first of all, that formula just didn't click with me.
Like when we were like, when I didn't want to plug the paper, I was like, oh, that's how they're doing it.
So,
Like, it just didn't click with
anyways,
me.
alright, so notice, we need to do a couple of these observed minus the expected. So what was the first observed value there?
Like,
80.
80
80.
minus the expected for it is 76.986
I'm not right.
squared divided by the expected.
176 by 96.
Can we just dot it out? I don't wanna write anything.
Just do 2 at least.
Oh.
Plus
Well, we know we're gonna be.
I'm gonna get an I, bruh.
84. I'll fight you if you get an eye on this. 84.6.
Oh, he's gonna be real mad when I get that 4.
Uh-oh.
You ain't doing it.
Oh, okay, yeah,
Bet,
you're right. I'm gonna get the 3. Bet.
Okay, so plus dot dot dot. Show at least enough substituted in that, so they know how to do this. And then we've got a chi-squared.
No,
Of greater
Are you
than
pressing it?
13.94. And so what is the probability that chi-squared is greater than 13.94 with a degrees of freedom of 4?
0.0075.
So how likely is this to happen by random chance alone?
No.
Not very likely, so we're gonna do what with our hypothesis?
Reject.
Reject the, which one?
No.
Null. There is conclusive evidence for the alternative. Make sure you compare your p-value and you got your context in
I
there.
don't wanna
Follow
know.
up.
Follow
Thank
up.
you, I was gonna say, because there was statistically significant evidence, we need to do the follow-up. Thankfully, they give us a component matrix right here. So where do I see because most of these are pretty small values.
The
What was
the very last one?
The very last one, the very last 2 to be honest.
TBH.
So, looking there, that's what's contributing the most to my statistically significant results.
You only need one though, right?
Yeah, but I would probably talk about both of them because they're pretty large. So, the group of individuals who have a majority of rare baseball cards and have been collecting for 16 to 20 months or 21 or more months were the most different from what was expected, and so they're the reason why there does appear to be an association between type of card you have and the number of months spent collecting. So, didn't have to do all that, but that was to help us practice. All right,
I do a lot.
that's everything that I wanted to cover today. Now, I'm
Found
going to
it.
stop, and I want you all to look at what questions you want to work on.
Just in
Stop.
time.